Hey everybody, it's Rob. I'm back. I'm going to do another video. I'm going to do something a little bit different today. This is a follow-up video, but also is going to give you, hopefully teach you something. Because I definitely learned some stuff going through this process. I had previously done a video on Proving Grounds walkthrough for Kevin, which is a Windows machine that had a vulnerability in the HP Power Manager. And an astute viewer of the video, Pelax is his handle, pointed out that I probably gave up a little too easily on this first exploit, which I have linked in the description below, and I said it didn't work for me. Well, if I had actually taken the time to look at the code carefully, I would have noticed that this shellcode was generated with msfvenom, and the author was kind enough to give you everything that you need to generate a new shellcode payload in the form of the encoder and the bad characters. Now, the bad characters, if you don't know what those are, they're essentially characters that could potentially cause the code to either not work or potentially crash the system. The bad character codes are typically like carriage return, line feed, things like that. So it's desirable to strip those out of the code, and msfvenom will do that for you automatically if you provide those bad characters when you generate the shellcode. Now, I have used msfvenom plenty of times to generate binary payloads, but I had never used it to generate shellcode payloads. And I had to do a little bit of research to figure out how to do that. There's actually a command you can run to see the encoders that are available in a msfvenom, and it's tac-l encoders. Now, the first hurdle that I ran into is if you go back and look at this code, he tells you he's using pex alpha num, okay? And if you come over here to the list of character encoders for that, that is not on here. So I actually had to go look on Google and see if I could find an example of how what this encoder should look like. Okay, so it has the architecture and then the encoder name. This is obviously not the encoder name because I don't think I think I tried just using this and it did not work. Okay, so I guess the best thing to do would be to show you exactly how to generate the shellcode and what you need to replace in this script to be able to get it to run. I am connected to Offsec VPN and I have Kevin up and running, okay? So if I come over here to my mouse pad, you can see I have the original exploit in here, okay? And you can see here's the original shellcode, and this is the exploit that did not work for me. And just to refresh your memory, this exploit generates a bind shell that you can connect to on port 4444. So Pelex definitely set me on the path, by pointing out what I had done wrong. So I really did have to kind of monkey around with msfvenom to eventually get the proper shellcode. And I'll show you exactly what I ended up on. Copy, paste. And I'll tell you how I got to this. So what I want to do is I just need to change this to C before we do anything. I looked at the second exploit, which is linked in the description below. And this is the one that worked for me. And the gentleman who did this code was kind enough to put the actual msfvenom statement he used to generate his shellcode. Now the difference here is, because you could tell this shellcode looks different. He used a different encoder, first of all, alpha mixed, and it's in a different format. It's formatted for Python. So I started with this as a base for the command that I was going to use to generate the shell. And then I changed a few things, and I'll explain this entire line to you so that you know exactly what each of these things does. You have msfvenom payload is going to be Windows shell, a Windows bind shell, okay? That should look fairly familiar to everybody, as this lhost and lport should as well. lhost is going to be your attack machine. lport is the port that you want the bind shell to appear on. And just a reminder, this is not a reverse shell. It's not connecting back to us. It's just making a shell available for us to connect to on the machine. Okay. Exit function thread, just don't worry about that. Just make sure it's in there. This tac B is where you tell msfvenom what the bad characters that you want stripped out of the shellcode are. Okay. So there's a pretty long list for this exploit of bad characters. A lot of the lists that I've seen for other exploits are much shorter. But both exploits that I tried have the same list of bad characters. So I'm not sure who developed what first, but if the author is kind enough to provide that to you, that's very valuable information. And you should take note and include it in your payload generation, because it will make your code stable and potentially prevent system crashes. The next thing we did was we have the format of the architecture of x86. And here's where I had to look this up, this PEX_alpha num. If you look at the original code, he just has it listed here as PEX alpha num. So I needed to find out how to format that correctly. Okay. And I was able to find that pretty easily on Google. And then the platform is Windows, and the format we want to generate the shellcode in is for C. Okay. So if you hit enter now, it's going to take a second, and it's going to generate the shellcode for us. Now you can see our shellcode is much shorter than the original shellcode, and it'll tell you up here it attempted to encode the payload with Shikata Ganai, and it eventually used call dword XOR for the encoding. Okay. What you actually need here is you can pretty much ignore everything except the actual shellcode, which is from this quotation mark down to this quotation mark. You don't need that semicolon. Okay. So if we copy this and we come up to mousepad, what we want to do is we want to get rid of all this shellcode here. So we're just going to highlight all this, and we're going to get rid of it. Okay. So now we're going to paste in our shellcode, and we're going to make sure we have that last parenthesis, because you can see the shellcode up here starts with shell equals open parenthesis, and then he has this identifier here, and then we have the shellcode that we're pasting in. So we want to end parenthesis there. Okay. So we're going to want to click save on this. All right. So now theoretically, we're ready to rock. Okay. This exploit did not work for me the last time. Now it should work with this new shellcode that we generated. Okay. So what we're going to do is we're going to close this, and we're going to come over here, and we're going to do exploit.py. And let's just make sure real quick. You're going to have to make sure that this is executable as well. So if you just created this file, copied the code in there, changed out that shell code, you have to make sure it's executable. So you just do chmod +x exploit.py, and then it will now be executable. Okay. So now we're just going to run the exploit pointing to the IP address of Kevin. Okay. So we're going to hit enter. It says the payload's been delivered, and that within a minute or so, we should have a shell, okay, to connect to. Now remember, this is not a reverse shell. It's not connecting back to us. We are connecting to it. So the command for that is this: netcat, the IP address that you want to connect to, and the port you want to connect on. Now, this may take some time, so we're going to hit enter, and we may or may not get the shell at this point. We do. So you can see, if you go back and watch Kevin, I tried for a good 10 minutes to get a shell out of that code, and using it with the existing shellcode payload, it did not work. Okay. But with the new shellcode payload, it works just fine. So that's my bad. I didn't know any better. This stuff is very complicated. There are many things to learn. But now I have another tool in my arsenal. I can, generate shellcode rather than just binaries, and use that shellcode in existing exploits when I find that, maybe they're not working the way that I want them to. You can see right here, it works just fine. Who am I? I'm NT Authority System. Now, just to kind of give you some background too as well. This exploit, although it worked, you could definitely change this code and customize it as well. Okay, and I can show you how to do that. This person was kind enough to give you the full msfvenom statement that they used to generate the payload, and they used alpha mixed, and it's in a format Python. And if you notice, there's a bunch of difference in the way that the code looks, and that there's these buffer statements. And essentially, this plus or equals typically means buff equals buff plus whatever, right? So it's essentially taking each line of this and adding it to the buffer individually. Okay, and this is in the format for Python. So if you wanted to generate code like this and replace this code that was in this original exploit, we could very simply do that. There's another, I have another msfvenom statement here we can walk through together, just so that everybody's clear. Paste clipboard. And if you look, there's some subtle differences here. Pretty much everything, I would say, up to here, the architecture is the same as the previous payload statement that we generated, right? The difference in this one is it's a different encoder. This one's alpha underscore mixed. Platform is the same, Windows. Format is different. So Python, this is different, and essentially this is different. The alpha mixed, the architecture, okay? So when we hit enter on this, you're going to see the code looks different, and it's going to match what's in that code in the exploit. So what you're going to need is you want this right here. So you're going to want to copy this exploit code that we just generated and replace this. And if you do that, this exploit will work as well. Okay, I'm not going to run it again because what I found with Kevin is once you exploit this using one of these exploits, the other exploits won't work. It just will say the connection's refused. So I'd have to reset the machine and everything. But I assure you it works. Okay, so I hope this video is helpful for you. I learned a ton on how to generate shellcode payloads and how to modify exploits that maybe aren't working for you. And just to shout out again to Pelix, because he said something very insightful. I don't know if he realizes if it was insightful, but it was. He said generally the most common exploits are the ones that are the most popular and the most common are the ones that you want to use. And since this one is in exploit DB, it's probably the most popular. So essentially it should work. You just have to make it work, right? Not all these things are just going to work out of the box, right? I mean, we're all kind of, unless you're developing these things yourself, we're all kind of script kiddies. But to just expect an exploit to work out of the box and not have to do any kind of modifications is kind of asking a lot, right? This is really a complex topic, and you don't want to just be searching for exploit after exploit after exploit. You want to kind of understand how these things work, and you want to kind of be able to modify them so that you can make them work in cases where they may be giving you some trouble. Okay, so I hope this video was helpful. Like I said, if you guys see me doing something dumb, please point it out, because I have plenty to learn. I'm here, I'm doing this, I'm not an expert. I've said this many times, I am not an expert. I am here doing these videos to help myself and to help you, right? When you explain these things to people, it ingrains these concepts into your head. If you can't explain it to somebody, you don't truly understand it. So that's why I'm doing these videos. I am open to criticism and I am open to corrections. So thank you very much, and I'll see you guys in the next video.